be coming back to us because we'll get to a chapter on immunity. So, at this point, granulose, all right, neutros, eos, vasos. We're looking at most abundant, for the eos, for the vasos, okay? They will increase depending upon what the body may need to be attacking, okay? So, granulose, A granulose. The A granulocytes, lymphocytes, monocytes. Lympho, what is that help making you think about? Do what? Lymph nodes, all right? Our immune system. So now, our lymphocytes, they will migrate from blood to tissues of the lymphatic system. So we haven't gotten there yet, so we will. These survive for decades. So that is a much longer lifespan. They are second in abundance in the blood counts and have several subclasses, which we will get into in future chapters, okay? And they'll have different immune functions. Monocytes, they can migrate to tissues. No, I didn't say lymph tissues, okay? Monocytes can migrate to tissues from the blood and live for a few years.
What was the lifespan that was 120 days then? Was that just for the
The
white?
red blood cell. The red blood
These
cell.
are other types of white?
These are the white blood cells. Now, it is these cells that are responsible for antibody production. Okay? These cells, the lymphocytes, the monocytes, are responsible for our antibody production. The monocytes are third in abundance. They will rise at a time of inflammation and viral infections. So which one was it that was bacterial?
The neutrophils.
The neutrophils. Migrate out of that bloodstream. They transform into what we call a macrophage because they are big and they eat, okay? They're highly phagocytic. The other part about this with the monocytes, they act as an antigen presenting cell. All right. These are the cells that are going to give us T cells and B cells. All right? You've heard of T cells, right? Have you ever heard of B cells? All right. So, having the T cells and the B cells, they will tend to go from the blood, go to a lymph node, kind of be in an area where if they're needed, they'll proliferate and that sort of thing. And they're really good at producing antibodies. Now, T cells, they're really good at helping us against stuff like viruses, tumor cells, microorganisms, tissue graft rejections. But now with a monocyte, all right, under these monocytes, when they go to do their job, all right, so let's say they've been in circulation, they've reached the size they're supposed to be. They're going to migrate out, and let's say they encounter something, all right? So if they're good against inflammation and viruses, all right? Now, viruses. Because right now, what have we got going on?
Coronavirus.
People stop the panic. Please
Yeah.
stop the panic. Okay? But it's a virus. All right? But y'all do know viruses are everywhere, right? Okay? Yeah, every time you probably touch a doorknob, touch a button on the elevator. Oh my goodness, oh shoot, microbiology people swabbed like the handles in the bathroom, and it was hard. I mean, come on, stop it. Because we're exposed to it all the time. Healthy people are going to be fine. All right. Now, here's what will happen. It's really cool. Okay. I know y'all are thinking she just really needs help. Now, all right. So, lymph nodes. Lymph nodes, based on their structure, and because they'll have B cells, they'll have T cells, okay, sitting in there, and T cells are sitting in there like this, going, oh, not mine. Something just flew by, a little toxin or something. They're still sitting there. Oh, still not mine. Sitting there. Oh, mine! Woo! Ah! Okay, let's go, let's go, let's go. And so they'll go out and fight the war. All right? So, when we originally get infected, all right, and encounter that virus, let's say I'm going to rub my finger across the little desks here, and I'm going to do this, 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 I'm going to do that, I'm going to do this, blah, blah, blah. And then I'm going to, up nose, I'm going to wipe my eye, or I'm going to go eat without washing my hands, I'm going to do something I'm not supposed to do, okay? And I've now given the virus a good host, all right? And this will go, hold up, no, we're not doing that here, all right? And that monocyte will come along, and that virus that now has the host, me, okay, might be proliferating real quick, and that monocyte might be like, ooh, I need some help. We need some help from the T cells, all right? So what it will do, it will consume as much of that virus as it can. Break it down with its enzymes, and then it'll take a little piece of it and push it through its membrane and go, la, 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 la. And when it encounters a lymph node and it sees that T cell sitting there waiting for something, it will go, ah. It has now presented it to the T cell. And the T cell goes, yay, it's my turn now. T cell will get the B cells, T cells, B cells. They'll go start this whole cascade of reactions, and it'll go, bye virus, you're done, we won the war. All right? And then they'll simply go back to the lymph node, and they're going, okay, I got that virus up in here now, so let's see if it happens again. And the next time you come across that virus, that T cell goes, oh no, and you don't even get sick because it's already there fighting it. Is that not cool? That's cool, okay? I don't care what anybody says. Immune system is cool, okay? So we're going to come back to these, all right? They are our antigen-presenting cells for the monocytes. Under the life history of the white blood cells, okay, I already showed you in your text that picture where we've got that HSC, all right, giving colony-forming units and them giving rise to these different types of white blood cells, okay? So definitely go back and look at that. For the most part, white blood cells are going to develop in response to need, all right? That little chest tube, where it shows that little thin line of the buffy coat, which is the white blood cells, all right? Yes, under normal conditions, neutral would be the one most in number, but in the overall count, it's not very high, okay? But let's say that we were to get infected with a tapeworm, all right? And we're all happy and great because, you know, we're losing weight, all right? All right? Might not necessarily be looking good, might not have a good, you know, color to the skin or anything, okay? But you're like, woo, I like this. But you're getting kind of tired and wore out and everything because the poor tapeworm's getting all your nutrients, all right? Go to the doctor. Doctor's like, you got a tapeworm. Yeah, but I lost 40 pounds. Can't you leave it in there? No, we can't really leave it in there. All right. You got to take this little pill tonight, and it's going to cause it to die, and you're going to poop it out. And that's what happens. All right? Now, in the meantime, because eosinophils would be the white blood cell that would be working to help fight against that, their colony, that colony-forming unit, would be getting very stimulated so that it would produce more of those eosinophils. Does that make sense? All right? Because it would want to get it out into the system to help fight that invader. Okay? So, we can develop the white blood cells when needed. Like, for example, if we've got a bacteria, neutrophils would increase in number. All right? So, as that pluripotent stem cell differentiates, all right, they have the ability on those colony-forming units to receive a factor, meaning, all right, if this is what I have, do I have something that is maybe dealing with allergies? Do I have something that's bacteria? Do I have something that's virus? And the body, the chemicals, all right, this is what we're dealing with, all right? Chemicals from the body can stimulate the factor of the white blood cell we need. And they will simply produce more. Our red bone marrow, it can store some of these cells, and when needed, they can begin to activate. Our lymphocytes, the B cells, the T cells, okay, they will begin to be developed in the blood. But the cells that will become T cells, they will have to migrate to the thymus because they get exposed to the hormone there and become a mature T cell. B cells will get developed, they'll travel in the blood, but they will actually go almost rest on a lymph node to be waiting to do what they've got to do. So we'll see that a lot of what are going to be like T cells and B cells, they'll actually go to lymph tissues. Think about like lymph nodes, lymph vessels, tonsils, that sort of thing. They'll actually go there and wait because they will be areas that would encounter a lot of these toxins or pathogens trying to enter us. The other ones, they can get produced rather quickly if we need them. If we think about those granulocytes, neutros, basos, eos, okay? So, the next part that we're going to talk about in this chapter, because we'll definitely be getting back into these cells when we get into the chapter on immunity. So now, and I've got a little video that I'm going to play. I actually stumbled across it yesterday.